Greetings everyone, how are you doing this lovely day? Today is Build an Amplifier Day. So I had a viewer graciously send in 8 authentic, they're from Mauser, TDA7294 power amplifier ICs. Wanted me to compare with the results I got from this TDA7293 kit, because I was getting some pretty interesting measurements. And we'll look at those in a follow-up video. I want to build the amp and test it out. Then in a follow-up video, we will do a comparison on the Quantasylum. So what's the difference between the 93 and 94? Well, they're really the same performance. The 93 has some extra pins, like a clipping detection and short circuit. A pin so you can easily parallel the chips together, and a bootstrap loader. Don't really need these for a typical amplifier circuit, so performance wise they're comparable. Anyway, the backstory of these things are this fella apparently worked. He's a technician who worked at I guess they're now defunct amplifier company. And he wanted me to compare these things, so he sent a few of them over. Anyhow, I had some questions for him. I was curious about what failed in the amplifier. Were these chips reliable? He said, yeah. Rarely had any issues with the chips. Their main failure point in the amplifier was the power supply. But yeah, the chips were actually pretty reliable. So that's good to know. So what I'm going to do today is build an amplifier. I'll just Perfboard it out and see if I can get a circuit I can compare. Okay, the thing I have to figure out is how to lay this out. The pins don't space out nicely because they're staggered, so they're not going to plug in. I could bend these row of pins over, then they'll sit in, but then I gotta figure out how to run conductor up between them. So yeah, that's a thing I got to figure out. Let's look at the schematic. Now let's see what I'm dealing with here. We have some bypass caps on the negative rail, positive rail, output network components. We have a bootstrap capacitor. That's feedback coming back from the output. Okay, that's the inverting, non-inverting input network components. Oh, the pain in the butt mute and standby stuff. I don't really care if my amp has a little pop or a click sound when it turns on. So I'm not sure I can get rid of some of these components to simplify that, because I'm not going to be using mute or standby. So yeah, I have to turn off the camera and get a layout set up for this chip and come back with some sort of result. Okay, I think I have a layout here. I like this graph paper because it's exactly the same pin pitch as the chip. Now the problem is these staggered pins, they don't fit, so I have to bend them over ever so slightly so now they line up. So the front row shifted over a half step there. So I think I got a layout here just to make this little test amplifier. So I got the signal grounds going off this way and the output ground and power ground coming into the star point. And the various components around the circuit, I'll have to double check my layout here. I'll probably change some things as I build it, as I find things are easier. There's a couple crossover points I have to deal with. It's just the way the chip's laid out. And maybe I can put that on the top side. I don't know. Or that one there. Yeah, I'll figure it out. But that's what I have so far. And here's the result. I still have to put the wires on it to connect it to the outside world. Not too ugly. Took the meter around, make sure I didn't have any shorts. I did change it a little bit from my layout here. For example, this resistor right there, I stood it up to save some space. Plus, you know what? I'm a stand-up kind of guy. The electrolytic bypass caps I did not put on this board. I just didn't want to use up too much of my parts. Plus I got these big guys that will be connected pretty close to the chip, so I do have those ceramic bypass caps there, pretty close to the pin there. But anyway, I need to hook this thing up and give it its first light up. Anybody catch my mistake? I had a 22K here and a 22K as part of the feedback network, and it's supposed to be 22K and 680 ohms, and well, I was putting that together and I said that can't be right. Wires are connected, tied them down, act as a strain relief. So as I'm moving it around, they don't break off at the solder point. One of the reasons I do YouTube is it kind of pushes me to do this kind of stuff. You know, normally I would, I'll eventually get around to it, but yeah, that's part of the reason for doing it. Will this work? I don't know. Did I get everything right? I did check around, make sure there's no shorts and all the connections pass through. I guess I won't get an answer staring at it. Let's get it hooked up and see what happens. Okay, let's just do this live on camera here. We'll power it up, see what happens. Okay, so we'll start at 0 volts. Turn it on, bring up the voltage. Current is 0. Should start to be seeing some action. That's a little concerning. Nothing. Let's turn it up higher. It could be the threshold of the mute standby circuit. Yeah, it should be doing something by now. No current drawn at all. Deader than a doornail. I have something not right here. Well, so much for that. It's not working. I don't have something right. Okay, I've been checking voltages and buzzing out connections with the continuity mode on the meter there. So I'm getting negative supply on pins 15 and 8, positive supply on 13 and 7. That's good. And the chip doesn't really have a common ground pin. It does have, a supply ground, I should say, but it does have ground on pin 1 and pin 4 right here. And I checked those. Pin 4 is grounded, but pin 1 is open. I checked my work, but I guess I still missed it. Let's see here. That pin right there is pin 1, and it's not connected to anything. It should be connected to this wire right here. I must have just missed it or something. Not too good, John, not too good. So yeah, let me connect that pin. That's part of the mute and standby. If that's not connected, it's not going to work. So let's see what happens. Okay, pin 1 is now grounded. Let's see what happens. We are powered up. Bring the voltage up. Oh, look at that. It's drawing current. 30 milliamps. No sound yet because we don't have enough voltage yet for the mute. Just bring that up. Ooh, I hear a hiss sound. Ooh, look at the current. Wow. Let's turn that off. It was drawing almost 2 amps. Let's take that above the minimum voltage threshold. It might do weird stuff there. Ooh, it's drawing. Turn that on again. 1 amp? Yeah, that's not right. I wonder what the problem is. Let's see, is that DC on the cone? On the speaker? No, the speaker's not really moving. That means could be oscillating. Okay, I connected the scope up to the output, and even with the speaker disconnected, yeah, it's oscillating. What is that? A 1 megahertz oscillation? So why would it be oscillating? Pretty good layout. I have all the small signal grounds coming over here, and the large signal, the output, is on this side. So they're separated. You shouldn't have any large signal ground currents flowing in the small signal areas, like the input. So yeah, maybe my circuit isn't good enough. I would think it would be. Okay, well, I'm not getting anywhere. I redid this mute circuit here the way they have it and applied 5 volts. Seems to be working. Yeah, I'm wondering if the mute circuit, the way it reacts internally, you know, if it wasn't set up right, it would oscillate. But, you know, I set it up the way they have it here, and it's not helping anything. I mean, I wouldn't think it'd make a difference, but I had to check that anyway. So yeah, I put some extra components for that. And I tacked some electrolytic bypass along with the ceramics to you know, help out, but that didn't help. I just don't see anything wrong. You know, the layout's pretty good. You know, the feedback's a pretty small loop there. So I'm not sure why it just oscillates. I built a lot of chip amps and never had this problem before. So I'm kind of wondering if maybe I damaged the chip when I left that open. I wouldn't think so. When pin 1 was left open. You know, I don't know how it interacts with the rest of the circuit there, but sometimes leaving, you know, a connection open could be a problem. So yeah, I'm at a loss because it just oscillates and nothing I try will stop it. And like I say, I don't think the layout's bad. It shouldn't oscillate with this layout. So the next move is to change the chip. So I think I'll try that. And I'm going to take some of these components back off. I'll change the chip and see what it does. Okay, it's actually about a week and a half later. Guys, I thought I was losing my marbles. I thought I was going crazy. I could not get this thing not to oscillate. I tried everything. I tried another chip. You know, the layout's not that bad. I mean, I got all the signal grounds over here. This is the bypass capacitor section. Power grounds over here. It's a fairly small and tight loop. Feedback is a fairly small and tight loop, even compared to the data sheet. It just would oscillate. I thought maybe there was something wrong with this. I think I mentioned it. I forgot what I shot in the early video. Something with this mute circuit. No, it wasn't the mute circuit. Yeah, I was just going crazy. I said, screw it. I pushed it aside. Gained my sanity back. And I started to lay out the circuit again. And during layout, I noticed something. I noticed, let me get my little pointer here, that the tiny little connection, this wire, this lead was connected here instead of here, so I moved it over. So what I was doing, this feedback network here, because of that connection, this point was connected over here, and that would shunt all the feedback signal through the capacitor to ground. I'm not crazy about the value of that capacitor. I used a different value. I used 47. It should be even larger. But anyway, that puts the amplifier in an unstable condition. And yeah, about nothing you can do will stop that from oscillating. So I fixed it, and it works. Yeah, it's just dumb little mistakes like that. And you don't see it. It is kind of hard to see. This is looks really messy, but it works. And it's a good layout. It should, perform here. So, yeah, it's those little things that get you. I was going crazy again. There is no way this amplifier should be oscillating. If the chips are authentic and they're working, there is no way this should be oscillating, and I just couldn't figure it out. And eventually I stumbled on the tiny little mistake where I hooked soldered the lead up to the wrong position, and okay, now we're cooking with gas. It's pretty quiet. A slight amount of hiss. I'm sure the camera won't pick that up, but not the quietest in the world, but not much to worry about. Okay, let's do a square wave test on this thing. Okay, it is square wave response time. I have the Field-Tech hooked up, and let's put some signal in. 10 kilohertz square wave. That's a nice looking square wave. So we'll crank it up. That's something weird going on at the bottom there. Look at that. Yeah, that's weird. How about 4 ohms? It's the same with 4 ohms. Back to 8. Point the camera at the scope. That, I don't know what to make of that. Why would it be doing that? I'll have to try the other board. This, let's see, this one here. I'm curious if it does that as well. There's really nothing in the circuit layout that should cause that. Okay, so what I'm going to do now is put the 0.1 microfarad capacitor, 100 nano, and see how it rings. Okay, you get a ring, completely normal. It's nicely damped, no issues. How about 4 ohms? It's actually a little better. Oh, we go unstable though when that issue at the bottom goes unstable there. Yeah, that's intriguing. I wonder what's going on there. What happened? You can see the ring. Okay, we're into clipping. Not a problem with this other board. It's 4 ohms. Okay, back on the other board. And yeah, this is sine wave, of course, and I'm seeing that distortion again, starting around 20 volts peak. So it's not letting me get the full output. Looks like that's wave is fat on this side. It's thick, like maybe it's oscillating. No oscillation. That was a connection issue. But yeah, I'm not sure what's going on here. Maybe I damaged the chip when it was oscillating like that, the high current or something. I don't know. I'm going to have to investigate further. That's why you do these tests. It rings out these issues. Okay, fix that problem. I tacked this wire. I was tying the pin 9 and 10 together for the mute and standby, and I didn't really connect it very well on pin 10, and when I was moving it around, I broke the connection. So that pin was floating and it was causing that weird reaction. So when I soldered that on, now I'm getting the full waveform. I go to plus or minus 30 on the output, so I'm getting the full output now without that weird thing happening on the negative. Okay, now testing with the capacitor across the output, and no stability issues I'm seeing. Let's look at it at a lower level. It damps out. It's 4 ohms. Yeah, I'd say this amp, you don't really need the coil on the output to keep it stable. Okay, so after all the little misstarts and screw-ups, got a working amplifier. Good enough to hook up to the Quantasylum, which we'll do in the next video, and run an analysis of the power output and distortion and all that good stuff. So we'll wrap it up here. Thanks for watching.